the strings.
What's up, guys? Today we are going to be working on some inline six turbo stuff, which is not going to be this, it's not going to be that, it's actually this beautiful thing right here. So this is my 2005 GMC Envoy that has the inline six 4200. I'm trying to test and see if this thing is as good as a Ford Barra engine from Australia that we don't get here, because there's literally 300 of these things at every junkyard that you go to. Well, there's at least a couple, and you can get them for a couple $100. The wiring and everything on them I think is pretty simple. A lot of guys have actually swapped these into older cars like C10s, Fox body Mustangs, and freaking like Camaros and stuff. So last week I made this little kind of ghetto turbo system just to kind of test and see if we could get this engine to kind of handle boost, play around with it a little bit, do some burnouts, make some cool noises. But the 05s have a weird ECU where it's like an alpha N tuning strategy, and it won't read above atmospheric pressure. So we can't really do anything with that because we can't really like do any boost table things. So I found a wiring diagram on the internet for basically a pinout of the ECU. Got all the connectors labeled right here, and basically I'm actually going to depin or actually cut some of this stuff and actually pin this and wire it into an Ecu Master Emu Black. So there's no base maps, there's no nothing for this, so I'm going to have to kind of come up with my own crank trigger settings or figure out all that stuff. But this thing has a built-in map sensor, it controls drive-by-wire, it controls variable valve timing, all that type of stuff, which is some of the other things that I've seen. Some of the other people that run these, they run them on like a Mega Squirt, and they don't get the VVTi to work, and they don't use the drive-by-wire. So it's going to be an interesting concept. Basically, I'm just going to start going through some of these wiring diagrams and just pinning it into here, and I'm going to leave most of the stock ECU if I can, just so it will actually control the transmission. So this is an automatic with a 4L60E, so I want to be able to let the ECU control the transmission, so that just because the EMU Black does not have those capabilities. It has small auto tranny capabilities, but not enough to run that transmission by itself. So yeah, we're gonna see how far I get on this thing today. Hopefully we get it working. Kind of the plan is, again, just run two ECUs. I think we're gonna have to share some signals, like we're gonna have to share like the crank signal, so we'll probably kind of tap into that, and everything else we should be able to disconnect and go from there. So I'm excited to see if I can actually get this thing working. All right, guys, so we made a little bit of progress on this whole situation here. So give these guys a haircut right here. Cut some wires, basically spliced on the little EMU Black terminals, and put them in there. So like this is my TPS. This is a ignition 12 volt or ignition switched ignition. This right here is the crank position sensor, and I'm assuming I'm sharing the signal right now with the stock ECU. Hopefully we don't have any issues with it, like resistance or little pull up, pull down resistor. I don't even know what I'm doing here. We're just testing it. Hopefully I'll know what I'm doing here, that's how we'll know, is if it actually works. We're sharing the crank position sensor signal just so it has an RPM, so that it knows when to shift the transmission, and it knows if it started, and it knows to keep the fuel pumps running, and just a bunch of stuff like that. So yeah, I went ahead and used this little pin thing right here, kind of going back and forth, doing a continuity test and like buzzing a couple things if I got a little bit confused. But so far so good. We have all the injectors wired up. We have the ignition coils wired up. We have the drive-by-wire stuff wired up, I'm assuming, I hope, at least. So we should be able to control the drive-by-wire with the EMU Black, which will actually be pretty cool. So, I mean, because then it won't give us no limits or no silly stuff. You just hit the pedal and it goes, and that's it. So, yeah, I guess there's nothing left to do other than just go ahead and put this thing back in here. I need to give the ECU, I need to give it a power ground on both of those things, and I think that's about it. So no, ECU ground. So I need to do an ECU ground, and then I just need to give it battery 12 volts, which I'll do over here off of this little block. I'll probably just tie into one of those things, give it 12 volts, run my own ground wire. So I'm gonna go ahead and throw this harness back in here, basically turn the ignition and then play with some settings, build like a little bit of a base map. Not really even a base map, but just kind of change some of the settings like inputs, outputs and stuff for the injectors. And then what I'm gonna do is basically take it over. There's a built-in oscilloscope in the EMU software, so where I should be able to look at the crank position sensor, and it should have like a little waveform and kind of give me the skipped tooth. And then basically what I should be able to do out of there is come out front, hook up the timing light, and we should be able to see, you know, when number 1 is firing, or you know, something like that, to see if we're in the right zone. I don't know. I don't know if this is gonna work or not. We might have just like bricked this thing. We're gonna have to push it around for a little while. But again, this is my challenge for myself. See if we can make all this stuff work. All right, boys. So yesterday I got a little bit distracted and I did a live stream. So I talked about a lot of things that I was kind of doing with this thing on the live stream. But if you didn't see that, we'll go ahead and talk about it now. So I hooked up, basically pinned everything into the EMU Black. You could see, like right here, this is kind of my method. Is got this printout of everything, and I think let's go to a good page where it'll show you some things. So we have right here yellow, black, fuel injector 6 control G22, which if you come over here to G22 is injector number 6. And if you look right there, injector number 6, injector number 5, injector number 4, CKP, which is the crank position sensor, is B8, which is black 8. You come over here, B8 primary trigger. So that's pretty much what I did with it. So I grabbed the signals for going to the injectors. So it's basically the little pulse from the ECU that says turn on. Same thing with the coil pack. So it basically says, you know, turn on. And then certain sensors I had to use the signal from it and the ground. I had to tie it into a ground. So crank position sensor, that was one that wasn't showing anything in the built-in oscilloscope on the ECU Master. I'll show you guys that in a second. But basically I wasn't getting any pulses. So what I did is I actually came back over here, and you can see I did it with the cam sensor too. So we have this pink wire. This is the low, basically the sensor ground. So I tied that into sensor ground, and this yellow wire right here, this is sensor ground for the crank position sensor. So crank position sensor is down there, so it does the crank. Cam position sensor is right here, and basically they need to sync up, because for every rotation of the engine, I think the engine goes like 720 degrees, or maybe the cam does 720 degrees for every engine rotation. So there's all kinds of firing orders and different things like that. So in order to run this thing in full sequential, basically sequential ignition and sequential fueling, other than batch fire. So you could run it just off the crank signal and batch fire, and just batch like 1, 2, 1, 3, and 6, I think, something like that. You would basically batch those and batch the others, so it would fire them all kind of at the same time. Whereas we want to run this thing full sequential, so that's where you have to have the cam sensor so that it knows what rotation is on the thing. So again, I'm figuring all this stuff out as I go. I'm learning it. I'm running into issues. You know, stuff doesn't work, and then I figure out what I need to do. That's at least the whole plan for this thing. So I'll go ahead and show you guys real quick this whole oscilloscope thing. All right, boys. So right here, this is kind of ECU's explanation of the oscilloscope, kind of showing, you know, different trigger settings and different things like that. So this is what I got it to read off of that. So this is the primary trigger. You can see it goes, this is, I think, like a 7 tooth, and it's missing 1. So all these 1, 2, 3, 4, 5, 6. And then it has this little dash right there, which I don't know if that is the like kind of the missing tooth or what that is. Still, I'm trying to figure this out. And then the secondary trigger, which is the cam sensor, you could see it kind of does these two close together, and then it does a big one and a big one and a big one and a big one. So I'm kind of not sure exactly what all that stuff actually means yet, or how to tie it in. But basically what you do once you get to here is
so we have this set up. I'm just kind of playing with different, like right now I have a tooth wheel with 2 missing teeth. Earlier I had it set up as a Subaru, which is 6 teeth basically, and a missing one. And then so what you do is you say it's a 6-cylinder, and then the first trigger tooth, basically that is top dead center. So you say I want number 1 to fire at 1 at the first rotation. So then you go over here to like ignition outputs, and then so ignition event 1 happens at basically ignition event 1 would be the first trigger tooth right there. So that's kind of how you tie that stuff into it. So you say, hey, fire here, fire here, fire here. And then again, if we were going to batch these, you'd be able to batch them. There's some settings that you kind of put in there for batching that stuff. So one of the things that I think I could do right now is I'm waiting to hear back from Chris, that one of the guys from Ecu Master, does a lot of tech support stuff here in the United States. So I'm kind of sending him this stuff. We're kind of working through it together. He's kind of helping me learn a couple things. So goal is to start this thing by the end of the day. So hopefully we get there. But I think one thing I could do right now is actually take my my timing light and go out there, hook it up on the number 1 coil thing, crank this thing from the inside, and then actually watch if we're getting it to actually ignite on top dead center. So it's actually not syncing up right now. So as we crank it, you can see we have that little red button on the bottom, and that basically says no sync. But when we crank it, so that says synchronizing, but it's not in sync yet. And I don't know what settings I need to actually tell it. I think I just have the incorrect settings in it. So we need to play with it a little bit more. Again, I'm learning all this stuff for the first time, but it's definitely cool. Listen to that turbo though. That turbo. As you can see, we got it running with a huge combination of just trying tons and tons of different things and different settings and crank signal patterns, and basically telling it this was here, and had to do some stuff with the timing light. I basically drew a mark on the front of the crank pulley. A lot of GMs, they're like a press fit crank, so they don't have like a timing mark on it. So I basically took the number 1 spark plug out, put it at top dead center, and ran a mark right here on this thing, and then we pulled the timing light out and pointed it at it while we were cranking it. At first it wasn't even on there. We switched a couple of settings, got it closer, it was in the zone. I basically used this little timing advance thing. It was like 30 some degrees out. To get like close, I basically advanced it to get it right on the money, and then we adjusted that many degrees on the ECU, like basically the settings in there, and then it was pretty much right on. So from there, we were using a lot of it was the cam sensor. So we had to use a N1 setting, which again, I don't know all this stuff. So a lot of these like sensors and stuff, typically you have to have them kind of set up to kind of have like a strategy to read them. So here we go. This is my primary trigger right here. This is crank position sensor. This is the cam position sensor, and this is kind of how we did this. So we have it set up as a VR sensor pull up. We have a little filter on it.
we have it set up as a multi-tooth and rising. So then we have number of cylinders, number of teeth. If it was falling, I believe, since it is technically a 7-1, we would have to have this as 7 and then have the first crank tooth at 1, but instead it's 6 and it's 0. Again, I don't know a lot of the meaning behind that stuff. So then the trigger angle was initially, I think it was 50, and then we changed that to 65 to get it to basically line up directly on the crank. And then we have had a rejection angle on here because there was an additional, if we zoom in right here, there was something that we basically needed to ignore, and I think that might have been this. It was something like that. So that's kind of what that does. Again, Chris from Ecu Master in Texas, he was helping me out a lot. Basically, he hopped on, like we were on the phone for like an hour, and basically he was doing the team viewer, which he basically was taking control over the computer while we were on speakerphone, and we would just change a bunch of stuff, and I would crank it, and then we would look at the trigger settings, and we'd look at this. One thing, we actually got it to almost start. So if you look right here, these are all the settings that we have kind of built into it. So right here you have like a 1-tooth, a Nissan trigger, VVTi with 3 teeth, and when we were on the phone, he basically said that looks like a 4-tooth thing the way it was doing. So I was like, okay, well, let's put in this VW R32 4-teeth thing, and then we'd crank it over, and it would show right here on the bottom that it was synchronized, because previously it was not synchronizing. It was trying to sync, but it wasn't synchronized. And so we changed it to that. It would actually synchronize, and it would pop and spit and sputter. And then the other thing he mentioned when he was on the phone with me, he's like, that kind of looks like an N1 thing. He's like, let me know, you mess around with it a little bit more, let me know what you figure out. And we just cranked it, and it popped and popped and popped, and it would almost start. And then I just changed it to N1, and freaking boom, just didn't fire right up, but it fired up after some cranking, kind of how it does. So that's kind of where we're at with it. One of the issues that we're working with now is that we don't actually have the drive-by-wire connected. It's not working. So as you can see, and I was just revving it with my hand. You could basically idle it down by pushing the drive-by-wire closed, and then you could rev it up, but it doesn't have any fuel there because it doesn't see a TPS input. So yeah, that's one of the things that basically need to do right now. I guess you could get like a LS1 style throttle body, and they'll bolt up, or they won't bolt up. You have to make like a little adapter, and then I could actually use just like a cable and just use a TPS. So that's another option too. Or just let the stock ECU control the throttle body and let it do that thing. But for the drive-by-wire on here, there's tons of settings. So if we go, let's open up a new tab right here. So here we have the drive-by-wire parameters, and so it has this drive-by-wire wizard. So I have it set up as a like this Corvette throttle body or a GM. So then you come over here to the electronic throttle connection diagram. That's what's super nice about the ECU Master is if you have a question about a menu that you're on, you pretty much just come right up here to the very top, and there is that there's like a little question mark up there, and then so this shows how it should be wired. And I was just a little bit confused. I'm not sure. I don't have all these inverses. So I have the signal coming from the accelerator pedal position, but I don't actually have I have the position hooked up, but I don't have the position inverse. So a bunch of little settings and random things like that I just kind of need to figure out. I feel like we're really close. One of the issues, the other issue too, is the fuel pump. Since the ECU does not see a tach signal, it's not going to turn on the fuel pump, and since it doesn't see a tach signal, it also does not turn on the alternator. So I was trying to mess with a couple little things like that too. Basically, we just hardwired the fuel pump just to run real quick by jumping the relay, and then we're just running the jump box on it, to kind of keep the battery and stuff up. But that's pretty much where we're at. I'm going to mess with this thing a little bit more, mess with the drive-by-wire, see if we could get that figured out. Again, a lot of it was just trying to figure out this motor plus and minus, and I even inversed the operation a couple times, like inverse the motor. I have a 5-volt signal going to it. I have the position. I have the signal ground, but I don't have the inverse, and I don't have the signal ground for the PPS, which that should be all right, because we're getting a TPS signal, and I'm actually sharing that with the stock ECU right now. So we're actually getting a TPS signal, but it's in, when I have it on the motor over there, like when you give it TPS, you could hear it go, like you could hear it, but it's not moving at all. Like you could hear it whine differently, but it's just not moving. So maybe I just have something. I think I'm close, is what I think. But yeah, it's just super cool to be able to actually start this thing. And you know, I definitely wouldn't have been able to do that myself. So huge shout out to Chris from ECU Master for messing around with it for a while with me. So I'm gonna charge my laptop and look up some more settings. A little bit of an update. So I messed with the drive-by-wire a little bit more. Went ahead and hooked up the power, or the low reference, basically all the 5 volts, all the sensor grounds, the inverse, the pedal or the throttle position, the inverse of it on the throttle body, and then the only thing I don't have hooked up is the inverse of the pedal position, as well as like the 5 volt reference and that stuff going to the pedal. But it's inputting a throttle position sensor signal into the ECU. Like I could give it, it's at 0%, and then I give it 100% throttle and it goes to 100, and you know, it varies in between. So I was yanking off the throttle. I just went ahead and yanked off the throttle body. Some of the guys on the forum, when they do other swaps, they basically delete the drive-by-wire and they use like an LS1 style throttle body with just a cable and a normal like idle air control valve. Using the drive-by-wire would be really cool on here. I don't know why I can't get this thing working. I think I have the right diagrams. I probed everything. I buzz tested it from here to there to make sure I was actually running the right wires. One thing that I did notice was on the M plus and the M minus, it had 12 volts when the ignition was on both sides of it. So I don't know if that's good or not. But yeah, so that's kind of going to be the next major hurdle. Is just getting that thing done. After that, I think it's going to be getting this engine to be okay with being in this chassis. It doesn't have a tach signal, so it doesn't turn on the alternator, and I'm just curious if it's going to let it actually shift and do that type of stuff. I seen one thing about somebody converting over to a like a 08 crank position sensor, because I think it's a Hall effect sensor, so that's similar to this, where it actually has a voltage coming out of it, where the sensor that's coming out of there is a VR sensor, that kind of makes its own voltage, which is like an AC current. And I don't think that you could split those up, because it has its own sensor ground, unless I just gave 2 sensor grounds to both the ECUs and then shared that signal. But I really think that this ECU and the body control module and everything else is going to want to see a tach signal. The other option is maybe I could send an output through the ECU Master to that wire. Maybe it'll be okay with that. I'm not 100% sure, but that's going to be another hurdle to try to get this transmission to work correctly, I think. So lots of little things like that, but again, I'm not really worried about this whole chassis. If I have to hardwire the fuel pump, if I have to hardwire the alternator to get it to charge, that's not really a big deal. If we could get the transmission to shift, that's pretty cool. If not, we might go to like an external controller or do something with a manual transmission. Again, one of the biggest issues is you could bolt a transmission out of a Colorado on these engines, but you have to have a custom-made flywheel. So that's another issue with that. Yeah, that's going to be it for this video, guys. I appreciate you watching. If you guys are stoked on this project, let me know. I mean, I think it's going to be cool. It'd be cool to just go to your local junkyard, find one of these things that's wrecked, pull out a $300 freaking junkyard thing that potentially you could make like 500 horse, maybe 600. I mean, I don't know. Maybe it makes 400 horse and it freaking blows up right away. Maybe these things suck. Again, that's why I'm doing it. So hopefully you guys follow along and enjoy it. But yeah, thank you guys for watching, and we'll see you guys later.